The lives that can be saved, the property damage that can be avoided. There is something here that I had not heard about at any other institutions.
This is a really great example of letting students and researchers and faculty know the immediate impacts of the work that they're doing. When I tell my friends, like, oh, I'm working in a crane safety lab, they're like, what?
They're one of the top inventions of the human race, one of the most important things we've ever come up with. When things go wrong with these machines, there's incredible consequences for humanity.
If something's going to happen with a crane, it's going to be a significant impact event.
On April 27th, 2019, a tower crane fell from the sky in Seattle onto Mercer Street, and sections bounced into the street and landed on a vehicle our daughter was riding in. That's a day I'm never going to forget. It was a day I vowed that this is not going to happen to anybody else if I can help it. We're here because the Crane Safety Research Center was born and lives here at Georgia Tech.
Dr. Singles was one of the foremost experts in the country on tower cranes and crane safety.
All right, awesome, that's good enough.
He's built up a laboratory to do the necessary research.
I'm Professor William Singhaus. I am a professor of mechanical engineering at Georgia Tech, and I'm also the director of the Center for Crane Safety Research. That's just a subset of the mechanical engineering department, and we currently have about 40 to 45 people at Georgia Tech working in the center, as well as I think 4 at the University of Texas and a couple at the University of Washington. The Wong Foundation, the Wong family came to me and said, would you be willing to take on this challenge? And they were offering a very generous donation for me to take on this challenge. The directive was really try to save some lives, like figure out why cranes are tipping over, try to get the word out about why they're tipping over, try to develop some technology to stop them from tipping over, and then release that into the world. And hopefully the effect of that will be to save some lives. Given the ubiquitousness of cranes, given that they're all over the world being used in different ways, that's challenging to root out and find all the possible causes of accidents. Since there's 100 million cranes, there's probably 1 million different ways that it can run into trouble, that we can go south.
One of our most significant projects involves studying crane collapses and modeling how they occur. And that starts from how they're initiated and what causes them, and that includes things like wind and tip overs and structural failure. So we are doing work to model these crane collapses so we can predict where sections could end up.
If you walk around our mechanical engineering buildings, you'll see this huge emphasis on hands-on learning. You know, one of the oldest, biggest student-run maker spaces in the country. Students really do come here for that type of hands-on practical education that's combined, again, with the really, really strong fundamentals.
Labs such as the experimental methods lab or the system dynamics lab, you're able to really get your hands on, and we started going into crane safety research, and my project originally was kind of focused towards a controls project of how we're able to control the crane with the sensor, but as we kept working on it, the sensor developed into this cable angle sensor that doesn't contact a crane's cable. Anyone that comes into near contact of that crane could be safer with the use of this technology.
My job was to 3D print a model, tip it over, and compare that data that I'm getting from the model to the video analysis method and see if it's accurate. By taking the data that we're gaining from tipping over the small scale crane, we can kind of create a predictive model. It could maybe segue into an eventual future where there's a product where a crane operator can input our boom is this long, our crane weighs this much, we're lifting something this high, and we can detect if it'll tip over or not, because then we'll have this data set where we can extrapolate, hey, it'll tip over at these ranges, or it'll be safe at these ranges.
Essentially, you go out looking for evidence in the crane accident database. It could be a particular failure mode on a particular crane or things like that. The model trains on that evidence you found so far, and then it looks over the whole database and it finds the next most likely piece of evidence. You can build up evidence and make your case on particular safety issues very, very quickly. We have 7,500 different accidents, a giant database of accidents, and we can show maybe that 50% of these accidents are happening during assembly, disassembly, or reconfiguration.
Kate and I and our third group member work on crane safety standards, so we look specifically at different standards, whether it's tower cranes, locomotive cranes, and kind of dissect those standards to see if there are places where there's a weakness in them, and to find that weakness and how it could be improved, or how it could encompass more new technology, or to make crane operators more safe.
But it is something that's really impressive and very cool to be a part of, to see, because like Sabina was saying, there's so many people working on so many cool things, and to be able to see that and be a part of that is really special. I get to learn and see things through this research lab that I wouldn't see anywhere else.
And it just makes for a really, really complex, very, very rich, dynamic system modeling and control problem. And I think that's part of what these crane safety researchers are finding, that what from the outset might seem like a relatively straightforward problem actually is very, very rich behind the scenes. And so I think that's part of why you're seeing these students really embrace the work, and then use that as motivation to then lead to some innovative breakthroughs.
I think there's a huge opportunity here. It's really inspiring to me because when I toured the lab with Dr. Singhos, he's looking at equipment that we are using right now. It's equipment that I see day in and day out, and he's dealing with problems and issues that I see in real industry and real operations. So the distance between theory and practice with what they're researching is like that compared to some other investigations that are out there, other research that's out there.
It provides really good motivation and really good guidance to what they're doing, right? What does it mean to reduce failure? What does it mean to save lives? And what do we need to think about in terms of the way we design the technology, the way we think about failure? So it's a really good reminder of why we do engineering, right? Which is ideally, in some way, to make the world a better place for people, to ease their lives in some way.
I got to meet our sponsors and understand the story behind why this exists. It meant a lot more to me. So my work in research is directly impacting and helping people, and that's always what I've wanted my engineering work to do.
I'm very grateful for what the Sarah Pantiwan Foundation has done for the lab and allowing many students, not just myself, to work on projects that have real-world impact.
These kids, they know it's important work. They're even working on things in the lab on how to spread the knowledge that they have to other universities. And so the idea is to spread the information around, get more interest, and get more solutions.
Being in Dr. Singhos' class, but also in his research lab, has been very, very impressive to me. He loves cranes and he loves what he's doing and the work that he's doing in teaching undergraduates about it, teaching PhDs, helping people learn how to do research and like all of those things within the field that he loves.
So it was a big challenge to take on, a little bit frightening, because it's a big responsibility as well, but it turned out very well, and I think we have essentially a well-oiled machine now, chugging out good results that should make the world safer.